Okay, we're live.
Hey, everybody. Ines, William, it's great to have you guys. Module 7.
At last.
I know, Ines, you've been working on it for so long. It's been a long journey. And
Yeah.
William, I'm glad to have you on to discuss the different implication to biology and biophysics and, physics. And I'm so glad to be able to announce that Module 7 is going to become available at the end of this call. I'm really excited about it because it's an update to the unified course of the Resonance Science Foundation, and finally we are updating the course, and this is a course that everybody can take. It's a free course, and that we're placing on our platform, and it has been 7 years since the first course was placed, which is 8 modules. This module updates the course to what has been published since 2015. And so it's really exciting to be able to bring this to the world in a layman manner so that everybody can understand it. And Ines did an amazing job at writing this module. I edited it with her many times, and we've gone through as much as we could, sifting through the information to make it so that it's understandable to the layman, that it's approachable for the layman, and that it conveys as well the scientific knowledge that's been developed in unifying physics. And these unifications in the unification advancements that occurred and that's conveyed in module 7 is the advancements in scaling and describing the forces in relationship to scales, and the energy levels and the radii of structures in the universe, which involves the proton, the electron, and the universe scale, the universal scale, and addresses the hierarchy problem that has to do with the discrepancy in the density of the vacuum from the Planck scale to the universal scale. So the vacuum catastrophe as well is treated in module 7. And so all these advancements leads to papers that are being written right now. And that's why I'm so excited as well, because the event of bringing module 7 onto our platform is actually a stepping stone to module 8, which will follow shortly, which is describing the physics that are being written right now. And so these are module 7 is critical to understand the development path, and as well, the information requires so that module 8 will be an easy understanding of the complete unifications of all forces, scales, and constants in physics, which is a more technically challenging paper to read. However, with the knowledge you will gather from module 7, you will be well prepared to understand that level of physics, and it will be actually an easy step forward there. So Ines, how is it writing module 7?
Yeah, hi Nassim, hi William, hi everyone. Well, it was a challenge, it was an honor. It's a huge responsibility as well for me. But it was a challenge mostly. Yeah. Well, many of us know that when you understand, when you have to explain something, is when you realize how much there's of it. So it's like for me going at such a level where I had to explain almost everything was a challenge because I realized myself had things that I didn't know that clear either. So it was a learning process for me. So that's what I loved most about it. I learned like I redid many of the things in physics that I thought I had already learned and knew already very well, and so it seems like I was learning on the go, and that was beautiful. So
Yeah,
at the same time that I was
because
learning, I was
because you have a background as well in solid state physics, correct?
And my background is chemistry. I did my
Right.
major in chemistry, and then I did a PhD in nanotechnology, in physics and nanotechnology. But it was basically my background is basically molecular and atomic physics. That would be like most of my background in physics would be that.
Yeah, and so
So
you've studied the electron in details, and actually you're
yeah,
preparing papers currently
yeah,
describing the history of the electron theory across the ages and the various approach
yeah,
to solve some of the major problems in physics. So it's good to see that you know, even at that level of physics, just mentioning that even at that level of physics, many questions remains unsolved, and some of these new physics, of course, the unification of physics starts to resolve some of these issues. So tell us about what you learned.
yeah. Basically, while doing the Model 7, I was also working in the electron review paper, which is something that surprised me a lot because I'm not aware that there were aspects of the electron that were not fully understood. And I would even say that were kind of like hidden down below the carpet, below the rock, so that we didn't quite get into that as well. And so it seems that that was precisely the thing that showed me we have many things in physics that we have we usually try to go towards what we understand. And those things that we don't understand, we don't feel we understand completely, we just try to avoid because maybe, I think it's because of the competitivity there is also this domain. You have to keep upgraded, you have to be competing with many other groups and all that, so you have to keep publications, articles, you have to give class of the time, and so that's a huge load of work as well. So at some point you just feel like, okay, I'll just skip that part and go on site I really understand. And what I found amazing is that now everything explains beautifully with the pieces of the puzzle that the graphic theory provides. And that was like, whoa, because you see, there are many topics in physics which are so well described and so rigorously explained, but they don't seem to connect to each other. They don't seem to fit. And so you see that it's like islands. These are like islands, and they're disconnected. And so you get into this island and you find such a rich scenario of concepts of mathematical equations and beauty. But then you see, okay, but where does this lead to? And you don't have any connection. And so you have to out to another island and you see, oh wow, look at that, but how does this connect to the other island? And so you go like that in physics. At some point, see, like the image is the sea, well, it's the space, the vacuum, connecting all physics. So that's somehow the same image I find here, because it is the piece of the puzzle that it's and enabling us to connect all the pieces of the puzzle is now complete, I would say, because of the article, the paper that you're about to publish for module 8, that would be like, whoa. I mean, that's where you see that this puzzle is completed, that the pieces were already there. Many of the pieces were already there, but the main piece connected these islands, which is basically the sea, the water, the vacuum, the space.
Yes.
That's the
collective.
richness.
That's the connective link between all the islands. I love your analogy of the islands, and it's so true that in each one of the islands there's so much richness in both formalisms, but as well in various approach to the formalism, that have validity as well, because there's a lot of unknowns, as you were saying. Just in cosmology, dark matter and dark energy comes to mind as one thing. And this is one of the things that's resolved here. And at the atomic level, well, then there is a lot of unknowns. Just for instance, the fact that there's 21 free parameter in the standard model, and that there is as well big questions about the mass of particles, their forces, their charge, their energy levels, and so on, because these things are unknown, meaning the source of charge, the source of mass. The best for the source of mass is the Higgs mechanism out there in terms of the standard model. And it doesn't quite do the job. In fact, most of the energy is coming from the strong force. The Higgs mechanism only predicts 4%, and so on. But there's a lot that has been written, and the Higgs mechanism as well is a function of the vacuum fluctuations, right? The Higgs boson comes out of the vacuum. So we describe it right from the Planck scale, and then we scale, and we connect the islands that are at the scales at which they belong by a formalism that is actually quite simple, which is like a holographic mapping, basically, of the different scales. So it's holographic at each scale, meaning that the surface is encoding information, and the scaling is like a fractal function of the holographic structure. And in module 7, we address two of these scales. So the electron, the proton already was addressed, and that's in module 6 and in module 4. And the publishing of the holographic mass solution. But then in the module 7, we address the papers in which we solve for the electron with the same scaling function. And then we solve for the universe in the same scaling function, get the right answers. Those being the islands that Ines is discussing, connected by the vacuum fluctuation, which is the water between the islands. And from these different unification of these islands, then eventually in module 8 as well will be one of the islands being biology, William. And so we're pretty excited about what we're writing right now, and the collaborations we're having with other physicists on this. But do you want to talk a little bit about what you get from module 7, and what your thoughts are on module 8?
Yeah, sure. So, basically, we already, so the course had already been online like for some time now, and it had to be actualized, because not only have we advanced in the model itself, going from the proton now to the electron, and now to the cosmological scale through the vacuum catastrophe problem, also address the consciousness and cosmogenesis of the universe. So there were also many advances at both in the community, in the scientific community around the globe, that are heading in the direction of confirming the model, because these are things that are happening now so fast at the observational scale, experiments both in quantum physics and in cosmology with the observations they find. And now it seems like there's kind of like this crisis going on, because the models are no longer fitting with observations. And so, but I find it's like the perfect time for us, because at this moment, what I have decided, like I chose many of these news and articles that are also made by us in the research team. We have tested all of these observations at the cosmological and quantum scale as to provide the evidence that these things are happening, and that we are having a huge amount of validation at the experimental level, both at the cosmological scale and at the quantum scale. So basically, in model set, we have 6 sections. In each section, the first section is addressing the electron. And the second, so the electron in the sense of the holographic mass solution. But in order to do that, you first have to kind of introduce the history of the electron, see how quantum physics fits in, why is it that it predicts, and where does the equation, the known equation from the electron mass comes in very pedagogical way, so that you get a grasp of how is it that we got up to this point, what's the history of the electron mass. And also at that point, it was interesting to introduce some things that were related to the history of the quantum physics, like how did quantum physics emerge, like black body radiation problem, which is what issued the quantic part of the mass and of light as well, of the magnetic field. So in this section, you will also see appendixes, which explain in detail, like what is an electromagnetic field, why is quantization of matter, what is quantization of light, and you explain that it's explained in very simple terms, so that we all understand what is the mainstream approach and how is it different from what we are doing. At some point there, we also address because as SI units have been actualized, the system of units we use not always driven, let's say, or related to fundamental agents like quantum agents or vacuum agents, and that's been very recently changed. Now we have all mass units, time units, all the units we use are used as reference, these quantum and vacuum agents, which is pretty important in the frame of what we do in the holographic model. So there's a section which is addressing that as well. What has been actualized in the units? As well, we have a section that it's explaining in detail the proton problem as well, because you see, it is kind of misunderstood that because now we have the solution for the hydrogen electron, which confirms the radius that the holographic solution provides. It is thought that there's no conflict already, because it coincides with muon experiments. So now that we have the electron experiments and the muon experiments coinciding, we say there's no problem in the standard model of particle physics, and it's okay. And that's kind of misleading, because in fact, the only theoretical prediction that's correct is the one that's provided by the holographic mass solution. And the other ones are off by 4%, which is a huge discrepancy because of the scale. And at the quantum scale, 4% is a huge discrepancy. So yeah, for that reason,
I just want to comment on that. So basically, it's a little bit deceiving because articles have been written in layman journals talking about how now CODATA, basically the standard for the values in physics, the constants in physics, um, adopted in 2018 the new radius of the proton, which is 4% smaller, which was predicted by the holographic mass solution a few months before it was measured in 2013, and then confirmed over the years, over and over, using muons and eventually using electron scattering, and then realizing that you know, the quantum values from theory that were being, you know, being used to extrapolate the value, those quantum corrections were incorrect. They had to be, you know, ignored, and then they got the right value for the radius, the proton. And so they updated the value of the radius, the proton, and said, oh, we resolved the problem. It's the correct value, except that they had to omit, you know, the quantum corrections from the standard model to get the correct value. So, and as well,
Yeah.
the 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 issue being 4% might sound like a small issue to the layman, but 4% in quantum theory is another universe, meaning, you know, usually values in quantum theories are known to 10 to the 10 significant numbers, you know, in experiments. And in some cases, 10 to the 12, 10 to the 13th, or the minus 13. I'm sorry, 10 to the minus 10 and 10 to the minus 13. You know, numbers after significant numbers after the period. So 4% is like in another universe. It's not the same universe, you know, it's not the same physics. And the Rydberg values, meaning the Rydberg constants and other constants in physics, are dependent on this radius being correct. Um, and so this is one of the things that's really interesting as well, with which we discuss in module 7, is that the new values came as well with a change in the way values are defined in CODATA, meaning that some of the values in CODATA are thought to be exact. And that changed with the publishing of CODATA 2018, where all of a sudden the standard for all values became the Planck's constant, h bar. So multiple values in CODATA became the standard, you know, where these values are thought to be exact, and then all other values are based on this. And making the Planck h bar, or the quantization of angular momentum in quantum physics, you know, just so we are clear about what h bar represent, which is the base of eventually getting the Planck's units, which is the base of the kernel of space-time being, you know, the holographic mass solution, the correct solution that gives the correct radius and gives the correct mass. The fact that CODATA made this, you know, the standard for mass as well, you know, and so that the standard was no longer a ball, you know, in a vacuum chamber in Paris for the mass, you know, for grams, but it was actually a theoretical value based on the Planck structure. This is very important because this is definitely bringing the standard of physics to the Planck's unit, which is the basis of the structure of space-time as described in the holographic mass solution. So I wanted to mention that because that's a really big point about that. And, when I was asking the question earlier as well, I was hoping William was going to say something about the island of biology and biophysics. So,
Well, I'd be happy to chime in on that.
yeah, the module 7 doesn't address that part directly. I think maybe a little bit, or
It does a little bit.
oh, okay.
Yeah.
Yeah, I don't remember the last review I read of it. But basically, we, so let me just preface, let me just start by saying that, okay, so this radius accuracy is really important that we were discussing. And then we publish papers with Dr. Amira Valbaker and with Olivier Alérol, Dr. Olivier Alérol, a physicist from France, on the electron and on the vacuum catastrophe, but basically that the electron radius could be extracted from the same holographic mass solution and the right radius. And then so you can imagine that that has an implication to biology, because we're talking about charge here. We're talking about, how charge is related to the proton structure and to the vacuum structure and all this. And so we could go into like energy production there, but let's ignore that for now. And just go straight to biology, because I think that's something that our viewers would appreciate.
Yeah. So, my background is in molecular biology. So, this is looking at what all these little nanomachines that make up the cell, that do all the work in the cell, what they are, how they function, all of these things. And a really big and outstanding question for me is, how did all of that get started? I mean, this is like an amazingly intricate and complex network of chemical systems, really. The biochemistry that's occurring via the molecular biology of the cell.
How many per second?
For a single cell, I mean, you're talking about hundreds of billions of reactions a second.
Right.
And it can be a tremendous number of chemical reactions a second in some cells, like your white blood cells that are walking along the tissues inside your body, looking for invaders and all this. In order to treadmill along those tissues, those are chemical reactions that it uses to move forward. And so, I mean, just billions and billions of chemical reactions every second, just moving one of these cells forward. So, I mean, when you take the totality of all of this information processing that's occurring via these chemical reaction networks that animate the body, the number is astronomical. The number of these kind of chemical reactions.
Pretty good Carnot engine.
Yeah.
It's like running at 100-degree Fahrenheit, 24/7, for 100 years, hopefully, at least.
Yeah.
And it doesn't fail. And if it does vary a little bit, it's not a good day for you that day, right? So they can't slow down too much, those chemical reactions, right?
It's really amazing that you're kind of at, like, in scientific terms, you're at this like critical point, right, where you're on this like razor's edge, and it's amazing how well balanced your body is, because even a slight deviation from that razor's edge and you're probably not having such a good day anymore.
Yeah, even a small deviation in pH level in your blood plasma, isn't it?
I mean, just a few percent, and you have acidosis, alkalosis. I mean, it's astounding the kind of regulatory pressure that is required of the body to maintain homeostasis, and it does it every second of every day, in most cases unfailingly, and allowing you to have hopefully a very good day.
Yeah, a pH level that changes by 0.3 is a really, really bad day for you, right?
Yeah. I mean, one of the largest systems in the body is the pH buffering system, because so many of the biochemical reactions that are necessary for maintaining normal functions of the cell have a very, very specific pH threshold, and slight deviations in that can stop the whole show. So
that pH is a relationship of electrons in the body, isn't it?
yeah, and so if you're looking at, like, okay, fundamentally with biophysics, even the chemistry, the fundamental dynamic that's occurring in the biological system is the exchange of electrons and protons. We call that chemical, but really that's electrical, right? Because you're talking about the movement of charge.
Exactly. So negative charge, positive charge, exchange, right?
Yeah.
Across a membrane, across a cell membrane, right? So then that starts to relates very straightforward and quickly to the holographic mass solution, which is exchanging information from the volume to the surface of a membrane, right? Like the vacuum fluctuation at the proton level or the electron level, as we demonstrate in module 7 now. So this polarization that happens, you could think of it at the Planck scale as the polarization of the vacuum, right? Or at the biological or at the atomic scale as the polarization of the proton or the electron and the electron. And then at the biological scale, you see it again, right? You see it again. And when you see it, it's nice because it's larger scale. So you can see what it does, how it works, how it's exchanging, right? Ions and protons and so on, and how the information is moving. And you come across a thing that is called a mitochondria that has little motors that are actually extracting, because you're looking for the source of the energy, right? And the source of the energy for this thing that's running this cell is ATP, right? And ATP is produced by these motors on the mitochondria surface that spin. And how fast do they spin, William?
So we've done a little bit more calculations on this, and so it kind of depends on the proton concentration, going back to pH again. It's extremely sensitive to the pH of the inner compartment of the mitochondria. But so it can go as fast as 60,000 revolutions per minute. It's all, and again,
60,000 RPM.
And again, we're talking about how many chemical reactions are occurring in the body. That's protons being moved across this membrane. That's proton exchange across this membrane and electron exchange. And you have so many exchanges occurring that this motor is able to spin up to 60,000 revolutions per minute. And you have hundreds of those motors in a membrane in the mitochondria, and you have hundreds to thousands of mitochondria in the cell. So I mean, it's an amazing amount of energy, and energy.
energy factory of like spinning Brownian motors, right? Type of thing. That and I mentioned Brownian because I'm relating to Brownian motions, and papers have been written on this, but there is a amazing gradient or flow of energy. Let's to put it in layman's term, that is occurring at the surface, and the result is ATP, right? And how much ATP you produce if you do nothing in a day?
If you do nothing in a day, you will, it's recycling, so the amount of ATP that you'll produce by putting a proton on ADP is equivalent to your body weight. So if you weigh 80 kilograms, you will produce 80 kilograms of ATP in a day, regenerate that much.
Yeah, so you've made chemical reactions that are equivalent to moving those protons, right?
Mm-hmm.
And like in equivalence to your body weight, if you do nothing.
Now, if you're sitting around.
Yeah. Now, if you run a marathon or go, climbing Everest or whatever, what happens?
So the amount of ATP that you're generating in those circumstances gets up quite a bit. You'll generate about a ton of ATP if you're running a marathon, climbing Mount Everest in a day.
Right. And all these reactions, the dynamics of these reactions are coordinated across the body, so that and this would be when you're running the marathon or you're climbing Everest. That would be like when it's spinning around 60,000 RPM, right?
Yeah, because you're talking about a lot of protons being exchanged.
Right.
Yeah. So that motor is moving really fast to generate the amount of ATP that's being required.
Excuse the expression, but it's going like a bat out of hell, right?
That's those are the words that were on my mind. Exactly.
So those are very, very high performance motors, these little motors, and they're in a fluid, right? They're in water, and they are producing energy that's really critical for life and for biology to be able to function. Now, biology function in such a way that once, like we're describing one cell right now, but there's 100 trillion cells, right? And or 50 to 100 trillion in a human, and this amount of proton electron exchange across the whole thing is not random, right? It's not like any one cell is like completely randomly functioning relative to the whole, right? They have to organize, they have to like work together. Is that correct?
Yeah, in fact, there's some really interesting research that has come out recently on synchronized oscillations of like your skeletal muscle cells, where actually this action of the ATP and the motors is occurring across millions to billions of cells, and they're actually synchronized exactly. So
very good.
Yeah.
And so you can see a direct correlation about their collective behavior, right? And the functions that they play in the body. Like you could think of, each like a radio set and that has multiple tuning stations, and one tuning station is like the bones, and one's tuning station, to think of it grossly, I'm making the analogy more clear, but basically you have coherent behaviors of collective cells, and there's a lot of them, because then your bones have to work with your connective tissues, that has to work with the blood flow, and with the nervous system, so that it actually fires at the right time, like for instance the heart, and so on. And there's a whole structure. Even you see in new developments, you see a lot of evidence of neurons and neurological structures, even in the heart tissues, in the gut, and so on. So that there's a interaction with the collective behavior and the singular behavior, meaning the energy transfer, right? The information cannot just be isolated to one cell. The oscillation of all the information has to come in islands of coherency, so that there's a certain set of information that's available, so that you can think of it as each cell being tuned to the same frequency, so that it's getting the right set of information from the structure of space, meaning from the proton and the electron exchange, right? Which is the fundamental mechanism for this, self-organizing structure. And then that self-organizing, those islands are connected to the other different frequencies, so that they're in harmonic relationship with each other, so that you have like the connective tissues work well with the bone tissues, work well with the muscle tissues, which work well with the nervous system, and so on. And so that whole thing that at the next scale has to be coordinated. And that's when you start to have a sense of the amount of information transfer that's occurring from the vacuum, to eventually get to energy level where you can start to think of accounting for the event of consciousness, or awareness taking place in the system, because of enough of a macro complex harmonic relationship between the frequency, that there's enough information moving through, enough coherency for the system to become self-aware, which is really, really important to understand, both in physics and in biophysics and biology, right?
Yeah, and it's pointing to where is the intelligence, even the sentience, the consciousness of the biological system originating. And kind of conventionally, it's pointed to huge neuronal networks, and this is where intelligence is emerging. But really, if you look at the physics, the fundamental biophysics, especially in terms of the holographic mass solution, this exchange of information, across boundary conditions, the intelligence, the sentience is originating in these metabolic networks at the most basal level of the energetic dynamics of the cell. There's intelligence and information processing and exchange that's occurring there, that's coordinated among millions, hundreds of millions of cells. That's where you're getting the foundation of consciousness, of a system that can come together and be self-aware like we are.
Mm-hmm.
So it's that's I think one of the most amazing things about what's coming out of Module 7, Module 8, and even what we got a glimpse of with the first holographic mass solution with the proton, is that the energetic dynamics occurring in the biological system that's driving this self-organizing autocatalytic chemical networks, the energy dynamics are also the information, also the intelligence of the system.
Mhm.
And so, if you have, even if you're looking at a single cell, the reactions that are occurring in there, the metabolism that's occurring there, there's intelligence even in the single cell.
Right. When you see those cells, to take the analogy you were talking about earlier, when you see those white blood cells chasing down an intruder, it's remarkable. Like they go right after it, and it's like no getting away from the thing. It's coming after you, and it's literally like a chase, a high-speed chase that you see, on television, of police, chasing down a car or something. And it's remarkable, and that's just one example. There's millions of those, of the way the system is working, demonstrating that, locally, at their size, there is a very specific, behavior and change, and it's not the result of just random cells bumping into each other and doing just the exact right thing by some miraculous, instant of some type of, fluke or something.
Yeah, I mean, the intelligence is starting at that level of like the mitochondria, that the proton and electron exchange that's occurring there.
Mhm.
So the intelligence is there in the cell, and then you're made of 50 to 100 trillion of all these extremely intelligent units. So the gestalt intelligence of your system is astounding.
Yeah, and the human, or the consciousness capacities of a human is astounding. That's what I think is the takeaway from this, and the nature of your existence, the nature of your relationship to the universe and the different scales. So if you don't mind, now I'm going to jump to another scale, which is the paper that was published, solution to the vacuum catastrophe. And,
Yeah.
and as well, there'll be uh, some stuff. Yeah, exactly. Right behind Ines there.
Right
You want
behind
to show
the
them?
bomb over there. That's
Yeah.
the catastrophe.
And,
I'm
this,
happy.
yeah. This might sound ominous to the layman, the vacuum catastrophe, and it comes from a way that the vacuum was first calculated, in quantum field theory. That is, in in physics, at the quantum level, there was an attempt to unify relativity and quantum theory, while a need for it, specifically for the electron, which was the work of Paul Dirac, that wrote quantum field theory and actually show the relationship between relativity, or between classical mechanics and the electron, like with a classical solution to the electron. And this predicted as well a non-zero vacuum expectation. That is, the vacuum was as a result of these equations. Quantum theory shows that the vacuum is fluctuating with um, a lot of energy, and that value is very high. I've been talking about it for 30 years. Everybody that knows my work knows about this, but I'll say it again. The value is 10 to the 93 grams per centimeter cube. at the quantum scale. So 10 to the 93 grams per centimeter cube. To give you an idea, the mass of the universe with all the stars and all the baryonic matter, all the matter in the universe is about 10 to the 55 grams. And so 10 to the 93 is some 39 orders of, or 38 orders of magnitude more energy in the centimeter cube of space at the quantum level than the mass of the universe. So just to put it in the context, so that value eventually, at the cosmological scale, separately, because in standard physics, those are two separate theories. At the cosmological scale, we discovered that the universe was not only expanding, but it was accelerating. And so that means that there was a need to reintroduce something that Einstein had removed, which was a cosmological constant. So just to give a little history there, Einstein, when he wrote his equations for general relativity, describing gravity in the universe as a result of the curvature of space, it predicted that the universe would be expanding. At the time, it was not popular to have an expanding universe. The universe was thought to be static. So Einstein, in order for his equations to be accepted in the literature, added a constant to his equation, free parameter to his equation that he called the cosmological constant. That would be a way to saying that the universe was static. Like he put energy, like a little more gravity in the space between the stars and between the galaxies, so that the universe would not expand. It would have just the right balance to stay in the same shape or in the same size, because his equation was predicting something different. And the result is that when Hubble discovered by observation using his telescopes and so on that the universe was expanding, then the cosmological constant was removed, because Einstein field equations were correct without a fudge factor, which was nice. And then eventually, starting in the 80s and then being confirmed in the 90s, the universe was found to not only expand, but accelerate. In that case, then the cosmological constant had to be put back in Einstein's equation. And in this case, it was given a negative energy. That is an energy that instead of like gravity being holding, it would be an energy that's pushing. And a negative energy is, of course, what is described in quantum field theory when it's describing, these fluctuation at the quantum level. So direct association was done to vacuum energy. So then physicists, astrophysicists say, oh, so it's the quantum vacuum energy that we didn't consider that's expanding the universe, which was really a good conclusion and correct, specifically for the holographic mass solution. But it created a huge problem, which was described as the vacuum catastrophe for the standard model, because it said that the vacuum was 10 to the 93 grams per centimeter cube at the quantum level, but at the universal level, we were measuring, or we were inferring from its expansion of the universe how much energy there had to be, and it had to be 10 to the minus 30 grams per centimeter cube, which is 120 orders of magnitude less dense than the vacuum at the Planck scale. So then astrophysicists said, well, you guys, you know, you Planck physicists got it wrong by 122 orders of magnitude. And the quantum physicists said, well, no, you know, astrophysicists are getting it wrong because that vacuum value is critical to quantum theory, and quantum theory is very, very accurate. So it must be the cosmological measurement that's wrong. And in both cases, so this went on for many years. And then I published the vacuum catastrophe paper, which actually resolves this issue, because it's not like one is wrong or the other. It's that in unified physics, this is not a problem, because you realize it's just the change of density between the vacuum expectation at the quantum scale and the vacuum density at the universal scale. Because of course, the density changed since the radius changed by 122 orders of magnitude, basically. So you get the right value. So basically, you know, meaning, so let me make it clear. So, you know, I just want to clarify this, because I want to clarify it in the context of module 8 that's, you know, that's coming out. Um, you can think of it as a decoherency. So the amount of energy that's available, right, between when it's really coherent at the quantum scale, right, and it's the islands are really defined, and they're highly coordinated, and they're really coherent, to larger structure that oscillate more, like the fuzz, right, in the hologram is higher, right, so they oscillate, and so they have a different energy level. And so you can think of it as like a screening, right? And of the energy from the quantum scale to the universal scale, meaning the amount of energy available from the quantum fluctuations at the quantum scales are 122 orders of magnitude less than the amount of energy available at the quantum scale from vacuum fluctuations. So then, you know, now this is a nice linear relationship, and when you do it, you get the right answers, you get the right mass for the universe, you know, by the way, and all the and the universe, as it does in the standard model, obeys the condition of a black hole. So, you know, you can describe it in terms of vacuum fluctuation and the holographic principle, which is applied to black holes in standard physics to describe their temperature. So you can do all this and you get all the right answers. And here I'm gonna kind of, you know, censor myself a little bit, because you know, some of the things have to do with what is coming in module 8. But these are really important things that all of a sudden relate, you know, the different scales, like from the Planck to the proton to the electron to biology, right? Which is like in between the electron and the cosmological scale, right? The you know, the planets and the stars and the galaxies and all this come after, and you can see similar behaviors. So then you can think of the universe as a membrane that's transferring information as well. And, you know, you can think of it as, you know, an information driving system that's creating very specific coordinated, you know, relationship inside it, except that these coordinated relationships are much less obvious because they are at a larger scale. We're in the very small scale relative to it, so we see only a very partial amount of it. And even the partial amount that we see organization. We see crystalline relationship. Like there's papers that were just published showing a direct relationship between filaments and galactic superclusters and neurons in the brain, right, William?
Yeah, yeah, they found a non-trivial, objective, mathematical correlation between the structure or architecture of the cosmic web. So, these are galactic clusters. You're talking about millions of galaxies and millions of parsecs of scale. And if you look, they'll have a node, which is a large, like supergalactic cluster. And then from that node, they have these long extensions that are just like dendritic filaments. And if you take a portion of that and you compare it to a portion of the neocortex or the cerebellum of the human brain, the correlation is almost like 1-to-1. So it's like the same kind of neuronal architecture that you see shaping the information processing occurring here in the brain. You see the same kind of neuronal architecture and the distribution and structure of supergalactic clusters.
Mm-hmm.
Yeah.
Well, this is really remarkable. And so, for the layman, we've been saying this, meaning like I've had that slide in my slideshow for I don't know how long, you have to, and and it's been in many other slideshows, because the relationship between the two seemed so apparent, and it was an analogy we were doing at the time. It's nice that now it's confirmed by formal mathematics. There is other confirmation of things that we've been discussing for many years, for some 30 years for me, where, for instance, structures of spiral galaxies and their arms is being correlated to DNA structures, William.
Yeah. So the double logarithmic spiral. There was this group that did this calculation on entropy, right? So let's say you have 200 billion stars and you throw them into like a globular cluster. So it would just be amorphous. And they ran simulations like what would be the most like thermodynamic stable configuration that has the most like entropic stable configuration. And actually the result is a double spiral, just like the DNA, the DNA double spiral. So this is actually a thermodynamically favored configuration. And it's one of those things where, there's this misconception that everything increasing in entropy equals increasing in disorder. These are direct examples where actually, if you follow the normal thermodynamic law of entropy, order can emerge from that. And actually, in investigating and showing the similarity of galaxies in these double spirals to DNA, these researchers actually came out and said the morphogenic field is real.
Right.
I mean, this idea that there's a field, what we call space memory, that is influencing the entropy and the organization of systems across scale from, the biology, the DNA at the center of our cells to the galaxies. There's this field of information that is ordering the organization dynamics of these systems across scale.
Yeah, and I want to mention that these papers, this one specifically is published in Nature, so it's not like we're talking about something really fringe. And it's remarkable that it's published in Nature as, you know, a relationship between DNA and spiral galaxies. You know, this is not, it's just beautiful scaling that you don't expect, you know, there. And yeah, so, Ines, did you want to mention
Yeah,
something about this?
yeah, because I wanted to add that these works that Nassim and William are talking about, this is part of what we have included in one of the sections corresponding to the, let's say, validation of the holographic model in terms of what I have seen through observations and through experiments. So this is one of the things that we have included, so that you can see that these works that we're talking about are also part of are really, really mainstream, and they are part of what we have collected in the Model 7. And so, and it also reminds me of, you know, we were talking about, it's funny because when dark matter was being, let's say, simulated computationally, you could already see these networks, these like neural networks. I saw these images of the dark matter, let's say. I would immediately say, but this is a neural network. I mean, there's no doubt about it. There's like, and this is their calculations giving this exact same result. So it's wonderful that it took some while, but it's finally been acknowledged that there's something really going on in between scales, that it's scaling fractally. And so that was just unbelievable.
I'm glad, Ines, that you mentioned dark matter, because you know, earlier I was mentioning dark energy, which is the cosmological constants, right? So to, for the viewer to understand, for laymen to understand, we went from so when we use our current equations to describe the universe, okay, its size and the matter in it, we fall short. Like the standard model falls short by a little bit. A little bit being the remaining, not what they fall short of. They fall short of the mass of the universe by 96%, the remaining being 4%. That is, the current equations only predict 4% of what's there. So the to resolve this problem, which is certainly related to the vacuum catastrophe, and you'll see why, is that they invented dark energy and dark matter in order to have the universe expand and accelerate. They had to add energy there, so that was part of the mass that was not considered. And the other part is that we have an issue with the way galaxies look relative to their mass, meaning there's not enough, and their angular momentum. This is really important. That is, they spin too fast for the stars to stay in them, right? All the stars should spin out of the galaxies, and galaxies should not form because of the rate of rotation they have. And so the solution for that was to add matter that we can't see, and that only interacts gravitationally, conveniently. That is, it doesn't interact with the electromagnetic field to produce curvature, like photons curving, you know, which we would see. And so it behaves in a very strange way. And this matter, when they had to add it to a galaxy so that the stars stay in it, to put enough mass in the galaxy so the star stayed in it, they had to add, you know, almost 80% the mass of the galaxy to do that. And they described it as this shell around the galaxy, this network that Ines was describing. And this shell, so this made up the under 96% of the mass of the universe that was missing between dark energy and dark matter, most of it being dark energy, which is as we described earlier, the vacuum fluctuation at the quantum scale, or the energy available from the vacuum fluctuation at the quantum scale, and then dark matter inside the galaxies. When we resolve the vacuum catastrophe problem for the dark energy, we resolve the dark matter issue as well, because our equation gives us the correct mass for the universe, but that is the total mass or the total density of the universe, not just the baryonic mass or the matter mass. So our equation doesn't get the wrong answer. So we don't need dark energy and dark matter. We can account for it with vacuum fluctuation at different scales. This is what the paper says. And so it resolves a much deeper issue than just the vacuum catastrophe. It resolves the issue of what dark energy and dark matter is. So I wanted to make that clear.
Yeah, and it also addresses the fact that why, when they take into account the contributions of mass into the equation of rational solution, why is it that they don't get that the universe is a black hole? So this is why we have also, by solving the vacuum catastrophe problem, also understand that if you have to add all the contributions of energy and mass in order to really find the Schwarzschild solution, which be the universe in fact being a black hole.
Yeah, very
so
good. That's another very important thing to let people know, is that, if you tell a physicist that the universe is a black hole, they might go and take the baryonic mass or the matter mass, which is only 4%, right? Because 96% is the dark matter and dark energy, and then stick it into Einstein field equation and see if they get the right radius for the universe. And they won't. They'll get a radius that's a little bit too big, too short. And, because the density, the equation for a black hole is, the density relative to, its volume, its size, right? The density of energy in a volume. And it has to reach a certain density to be called a black hole. And so since they're only using part of the mass that they actually have to put for the universe to look the way it looks, right? Not just the baryonic mass, but like the dark matter and the dark energy, which they have to put as fudge factor in this case. Then when you put that in the equation, then the radius of the universe is exactly correct. Like it's exactly what we observe. And so this resolves as well that the understanding that we live inside a black hole. And that might sound really foreign to the layman out there, to our viewers, or even the physicists in some case, because black holes are not well understood. But people don't realize that a black hole, let's just say, for instance, to give an idea to people, let's just say that I took the density of our atmosphere on Earth, right? Just our atmosphere on Earth. And I put the atmosphere appears not so dense, right? You don't feel it much when you're moving air, but you don't feel it much when you're moving. If you stuck all of that in the bubble of our solar system, like like there's a boundary to our solar system, right, which is the Oort sphere, that if I stuck the density of air on our planet, like the density of our atmosphere in all of the solar system, then the solar system will obey the condition of a black hole. So a black hole doesn't need to be very dense if it's big, right? If it's the size of the universe, it can be very low density, in terms of, the distance between things. And never mind that between the things, there is energy as well that you have to consider in the mass, which is the residual of the vacuum fluctuation that are occurring at the quantum level. And when you do that, well, then of course you obtain the fact that this universe is a black hole. So when we're talking about these different islands, we have to think of it as like Russian dolls of black holes, if you'd like, exchanging information at each scale and producing coherency. And so this is a really important part of understanding all this.
Oh, an analogy I like a lot that you use very frequently is that of the black coffee and adding milk to it. And so we're trying to describe the behavior of the milk without taking into account black coffee inside the cup. So it's like you will never have the solution. It's impossible. I mean, the dynamics is not coming from the milk itself. It's the black coffee, which is creating the whole dynamic. So you just see it because of the milk.
Right.
So I just find it
So of course,
so
if you,
amazing that
yeah. So of
so
course, if you account only for the milk, you're missing most of the mass that's making the thing happen.
yeah,
And as well, if you
yeah.
think of galaxies spinning without a source in the vacuum, then they're gonna appear like they're spinning too fast to retain all the stars. You know, if you don't realize that the vacuum has viscosity and that, you know, it was called in Einstein field equation frame dragging, and you know that so that the stars are entrained in the flow dynamics of exchange of information, and then so there is really an interesting part to this as well, is that at the cosmological level that people don't, you know, I've done so much cosmology. It's a scale I really love to think of, because as well, just like biology, we can see it. So I think it can give us really good hints on what goes on. And that really involves as well making our you know, like, so when we look at the way stars move in the galaxy, we can see that they have a very coordinated way of moving, right? Meaning they make these spirals that William was describing earlier as a result of the thermodynamics of the system. And in there, I could inject a lot of module 8 that's going to come in, but I'm just going to hold off on this. But, you know, as the thermodynamics develop, then you can see that this basic behavior, you know, which William was talking about at the biological scale as well, of the way things are moving, is fundamental to how the flow or the circulation of information is occurring in the vacuum. And the the movement you can expect would be similar if you thought of the Planck field relating to a proton or to an electron. And you would first note that the system is polarized, right? So that you would get a polarization of the vacuum, which is now like 25 years ago, when you talked about vacuum polarization, it was almost like you were talking voodoo. Now, vacuum polarization is well-known fact in quantum theory. In general, it's necessary for some very important equations there, and you know it is something that you can discuss freely now. And but basically, you can think that the space and time, or like the structure of space time, is polarized, whether you look at it as a galaxy, whether you look at it as a cell, or whether you look at it as an electron or proton. You know, you're looking at a polarization of the vacuum, which behaves in a very specific way to produce very specific flow of information, let's just say a very specific geometric relationship to space, that define an island of coherency, a structure, and this is emerging from the spin. So then people may ask, well, where's the spin coming from? Well, remember that gradient in the vacuum, 122 orders of magnitude gradient. A gradient of coherency in the vacuum would produce a very specific flow, a very specific dynamics. And then again, I'm getting ahead of myself and I'm starting to touch on module 8, but you can imagine that you have a information flow that drives everything, all the spinning information through all of the scales from a gradient, just like a little gradient between the temperature of the surface of the water on the earth and the atmosphere temperature can create a hurricane that's moving millions of tons of water and producing large electromagnetic discharges, that's producing antimatter at its core. We see antimatter jets coming out of a hurricane. That was very surprising. And you can see the relationship between a hurricane and a galaxy. So if you need intermediary islands, intermediary scales, a hurricane is a good one. And then you can imagine the gradient not being a few degrees between, hot air and cold air, but being 122 orders of magnitude just between our universal scale and the Planck scale, assuming that we just look at that gradient. Now, if there's sub-Planckians, which we can extrapolate now from our equations, and multiverses, then the gradient is infinite in both directions. But you can imagine that the energy levels at each scale resulting from that gradient is enormous, and it produces angular momentum. And just like a hurricane is produced from that gradient. So you can think, even as the mitochondria, motors are spinning, that it's part of that gradient at the biological scale. And, by the time you get to a smaller and smaller scale, speeds go up. And by the time you get to the proton scale, you're going at c. You're going very, very fast. Or at the Planck scale, you're going at c. By the proton scale, you're going very, very close to c. And that would be module 8, so I'm not going to give the value. But, that's been calculated as well. And it all works out so that we can estimate and calculate for the quantum scale very precisely, and then for planets and stars and galaxies and universes and multiverses, their radius and their energy levels and their angular velocity and all these things, so that we can understand the whole. And so I know I've been going for a while, but I this is something I would like to transmit to people, is that there is a direct relationship between that gradient as well and forces in the universe, which now are expressed as this gradient moving through, right? So when the gradient is in both directions, right? There's a gradient going in or there's a gradient going out, depending on which side of the horizon you want to look at it. And so you can imagine that forces are related to this, and that the forces are really the result of, you can think of it as a pressure on the horizon at each scale that you're looking at, because of the information transfer that's occurring in that region between what's going into the system and what's coming out of the system. And now you can start to describe the different gravitational and electromagnetic behaviors at a very fundamental level. That is, even at the biological scale, all of a sudden you can account for this exchange, not only in terms of its energy potential and its like polarity, right? Its polarization, but at even more fundamental scales like the van der Waals forces, or the strong force, the gravitational force, and all this, because you have a direct relationship between the forces, the scales, and then, as in module 8, the fundamental constants of physics, which all come together as well. So this is really, really important, and that's why I'm really happy to like be able to like bring the module 7 to the world at this point, because again, it's a really nice stepping stone to the basic understanding of what's coming in module 8. So to close on this, maybe some words from Ines and William on these thoughts, and then everybody, please help us bring the word out that module 7 is available. There's 100,000 people taking module 1 to 6 right now. I think all of you need to jump into module 7 right away. If you haven't read the 1 to 6 modules, it's really useful to understanding module 7, specifically module 3 and 4. So if you're only gonna read 2, read 3 and 4. 6 would be good as well, because that's the application of these modules, of these earlier equations and understandings. And then module 7 will make more sense. It's really important that you understand these fundamental concepts before you jump into module 7. But yeah, let's get 200,000 people reading. Let's get 1 million people reading. Let's get a few billion people reading, because we need to let people know that there's a way to the rest of the universe. There's a way to understanding ourselves, understanding the universe around us, and develop incredible technological applications for, not only living in harmony with nature, but as well thriving with nature by understanding it at its most fundamental level, which can have implications from energy production to gravity control to extension of life, as we discussed with William. The application to biology is remarkable too. And so these are very, very important things that can emerge from this, and that will emerge and are emerging from this. And so, I really encourage you to not only get involved, but let people know around you, and let people know that there's a new module, and that there's a module 8 coming. And let's really build this all together, folks. We need to let the world know that there's a view of ourself and the universe that can make a huge difference in our evolution, and that is making a huge difference in our evolution. Ines, to close.
Yeah, I didn't want to miss the opportunity to talk about the Nobel Prize this year in physics. Well, last year was it the black holes? Award Rose to Guess and Gamehart because of the black holes work. So I think that was like, wow, so beautiful information as well. And so that's the Nobel Prize I didn't want to miss. And also, well, you will see that I did some little comments while you were talking, just to topics. So about the Brownian motion, there's this work which is already experimental work where they extract, let's say, energy like current from graphene, exactly just from graphene, from the. So that's one of these amazing applications that are like, wow, showing us that this is something really important and that this is very important results. I also, when the Dirac equation was mentioned a while ago, it's fun because that's where I found out that these equations from Dirac was predicting a fluctuation in particles, and this fluctuation in particles was happening at the speed of light. So that's something of the things that in the electron, it's called Cedar-Bewigan, which is something I have been working on lately. And that's something that I would like to draw the attention to that, because there's a huge community of physicists working in that precise phenomena, which are claiming since many years ago, like 20, 30 years ago, that this is something that should have been looked further. And that we, because quantum mechanics and the Copenhagen interpretation came and like swept away everything, this other visualization, this other way of understanding the electron in a very classical way being overlooked completely. And so now there's interesting works that have been going on that are pointing in this direction. And this is a huge community of physicists would be very, very interested in, because basically Cedar-Bewigan, which means trembling along the way, electron motion, this would be explained only through the vacuum fluctuations. So that's something that's connecting directly with the holographic model and theory. And so that would be also, and this fluctuation was found by Schrödinger and Braid. So these are the ones who interpreted that fluctuation, which is very linked to the Compton radius. These are all very small words that you'll see once in a while in the model, but they're very explained. They're explained in detail in the model so that you don't get lost of it, because all of this will be connected at some point through model 8. And so, well, basically, and well, also other news, like they found there's Goldilocks zones on black holes. So apparently black holes have this region in their ergosphere could allow for life to thrive. And these are called Goldilocks zones in the case of suns. So we have apparently through the observations and calculations, we have seen that in black holes also is possible. So you can have these Goldilocks zones around black holes. And this brings me into this, this makes us question about our sun itself, because it's got a Goldilocks zone around. So these black holes are called like black zones. So that makes us think also that like these could be black holes. So that's a beautiful analogy I like to play around with. And so, well, I would say we have covered, so the electron work in detail. We have covered, we revisit also the holographic model. We revisit the principles of holographic principle and of the generalized holographic approach as well in extreme detail, as we can see what is the connection between quantum mechanics and relativity, which is given in that solution of the holographic approach. You will see it very clearly at that point. There's also, and then we go to the vacuum catastrophe problem, where it's addressed, it's understood. First, it is explained in terms of mainstream approach, say what is the discrepancy and where is it coming from? How do they calculate the energy density at the quantum scale? How the observations are something very different. And then we'll address that using the holographic model, and we'll see how, as Nassim has very well explained, it's completely solved just by accounting the vacuum fluctuations properly. You just have to take into consideration the vacuum fluctuations and how it organizes in space. And dynamics between between the surface to volume entropy and of the vacuum, let's say, and how it organizes. Then we go, so we have established all this, like, let's say, like background. We can go to the section 3, which is the cosmogenesis and the space memory network from cosmogenesis to consciousness, which is one work that Willem Brown and Amir Baker and Nassim Haramein have developed, where we can see that because we have already established how there's this network which is created thanks to this surface to volume ratio and the other relationships emerge from that, you can see that we have already properly set the stage for this network of entanglement to merge. And that would be like, let's say, the substrate on which the consciousness would be like occurring and emerging. And so that's a very beautiful section, the section 3, which explains, I think most of you will be really interested in that section, because it is there, it is explained. Let's say we address the issue of consciousness and why is it a problem in physics. So mainly because in physics, there's this discussion whether consciousness is emerging from, let's say, from matter, and it's only a condition that's emerging like from randomness, and suddenly we have some consciousness going on. And so you will see that there's like this huge division where physicists say, no, this is something only possible emerging from matter, from mass, because that's the complexity. That's where the complexity happens. And there's this other approach with the holographic approach, and many other physicists follow as well, which says that the information is not in the brain. It's a network, and see all these options will be discussed in model 3 in section 3 of the model 7. And then we end with 3 sections, which are just the experimental observation, the cosmological observations, heading in the direction of validating what we have presented in the three works. And way 3 works have been published in peer-reviewed journals. So there's a paper for the electron mass, the paper for the vacuum catastrophe, and the paper for cosmological consciousness. So, well, I would say that's on my. And for me, well, I could say it's been an honor and it's been a pleasure, and I've been like thrilled, amazed, and overwhelmed with all this knowledge that I have acquired and I have shared. And I only hope that you can enjoy it as well as I've done. And well,
thank you, Ines. You're the best. Thank you, Ines, and for your contribution and helping getting this out. And I know you worked really hard on this, and then there was a lot to do, and it's really exciting. And I want to mention as well, I saw comments go by about languages were right away working on translating that module in French and in Spanish, so we can address those audiences, and we'll do a Zoom meeting when we publish module 7 in French, and maybe we'll include Olivier Alérol, which is the physicist I'm writing physics with right now as well, as well as Ines and William in biophysics. And so that'll be fun as well, definitely. And Maria Carolina as well, when we published the Spanish version, and of course Ines, which is in Mexico, and speaks well Spanish. I'll need somebody to translate me. But William, you speak a little Spanish?
Yo tratando de aprender hablar en español.
There you go. William, any closing comments?
Yeah, well, just a second that notion that this is I think going to be a really impactful course, a new module. For those who take it, you're going to come out of it with a better, deeper understanding of unified physics, because Nassim and Ines did just an amazing job on making this relatable and understandable. So, as the biologist on the team, I know after going through module 7, I came away with a bit better, deeper understanding of unified physics myself. And really excited for folks to get to delve into module 7.3, because as Ines was explaining, we discussed the application of the holographic mass solution and how it's ordering information and giving rise to structure in the universe. And we extend that out to, other physical systems like biology. And what we find and describe is that, that the organizational parameters, the self-organization mechanisms that are bringing about life and living systems, bringing the first cells, those are intrinsically linked to information processes. So it's intrinsically linked to things like consciousness, a kind of delocalized consciousness, an awareness that permeates all the universe. And so we see that, well, the rise in the tendency for the universe to increase in coherency and increase in synergetic organization is linked with the information processing that's occurring. And that's linked with awareness and consciousness flourishing and emerging and expanding.
Yeah, so even when you're having a really big day of thinking, or processing, or experiencing, or meaning like increasing your awareness to your surrounding and all this, we could even think of it as spin changes in the mitochondria motors and so on. And so William, just in closing, do you want to talk about a little bit the papers that we published that are part of module 7, that because we're updating people on the papers that were published, and where you see it going?
Yeah, so we have the Unified Space Memory Network from cosmogenesis to consciousness, which is, it's describing in more detail than had been done before the self-organizational mechanisms at play in the universe. So how you can get order emerging. This has to do with like the anthropic principle, right? So why are all the constants tuned to just the right levels for there to be structure at all, an atom at all, for there to be a stable orbit of the electron around the proton? We can explain it from that initial most event, cosmogenesis, to the gradients that are established, that establish the energetic flows, that establish the exchange of information. So that's your organizational dynamics that lead us all the way to the biological system, where you have that same kind of organizational structure in place. These energetic gradients that are involved in the exchange of information, that is the intelligence of the system and what allows it to enter coherence and long-range coordination along a number of different subunits of the system. That is the cell, that's life. And so, with the new paper that's coming out with module 8, we're going to be able to explain in detail that has not been possible previously, how this organizational dynamic is coming into being.
From the most fundamental level, from its energy level, from the way it functions, its resonating frequency, and so on. So yeah, thank you, William, for all the great work you've been doing.
There's a final announcement. The model is already available.
Great.
So you can,
All right.
yeah.
All right, people,
Yeah.
go to
We've
the
got the head ups. It's already on the everything on the platform. So yay.
Everybody go to the Resonance Science Foundation, right? ResonanceScience.org and register if you're not registered. And if you are, just go to module 7 and start reading and enjoy. Super happy that we're there. Thank you so much, you guys, for doing the work you're doing. I couldn't do what I do without you guys and many others that are behind the scene, you know, that we don't see right now, that are working really hard to make this happen for you guys, for everyone. And you know, this is something that that always require everybody's participation. And so if you can become a member and help us and do whatever you can to propagate the information, it's really important. And you know, stay tuned for module 8 that's following right behind, module 7 in French and in Spanish soon. And well, thanks to everybody behind the scene that's doing incredible work to make this happen. And I think there's a little trailer that has been made for module 7. Go and check it out. And I really encourage people to discuss these matters, you know, on our forums and so on, and follow and, you know, ask questions and so on, and participate in our 2-hour question and answer sections we have every month, in which I participate. And then there's the faculty meetings as well, and so on. And so stay involved, stay connected, and until module 8, may the vacuum be with you. Thank you, everyone.
Thank you, everyone. Goodbye. Thanks.